really have got, well, it's not new stuff. Parallel, perpendicular, you know it. But I'm going to also show you what's called general form, which is this right here. So this you probably have never seen before. I don't know in Algebra 1 if they still teach standard form. Standard form might look familiar to you. It's this. So like standard form, just to give you an example, equals, I don't know, 12. So the only thing I find at all beneficial, and there's not a lot here, about standard form is I can look at that equation and get your intercepts. There's a good review topic. I can tell your x-intercept because if I put 0 in for y, it cancels that out. My x-intercept's 4. If I want the y-intercept, I put 0 in for x, cancel it out, y is 3. So it's the only redeeming thing about standard form. Not that there's a lot of redeeming things about it. General form I find even, well, let's be honest, less redeeming than standard form. Now, general form, there are some applications to it when you get into calculus. So all we're doing here this class is just introducing general form to you. The only thing I have to do different to pop this into general form is I'd subtract 12 over and set it equal to 0. And here's why I'm kind of like negative on general form. I look at that and I'm like, it's not super informative. Here, at least in the red one, I can get the intercepts in my head when it's set equal to 12. Here, not as easy. I also can't just look at that and potentially tell you the slope. I'd have to solve for y. So again, also not crazy informative. But general form, like I said, there's some applications to it, some uses of it in calculus. So all I want for you to know, general form, we set it equal to 0, just so that you can recognize it. So, sketch the graph of the equation. Now, 2 ways you can sketch this graph. I don't really care how you do it. We're in general form. I find general form not very helpful, not very helpful. So I'm going to first put it in standard form. I'm just going to add over 12. So from that point, you have choices. I can look at that right now and tell you the x-intercept and the y-intercept with, no work, okay? I could also solve it and put it in slope-intercept form and draw it off of that. Do I care how you do it? I don't care how you do it, as long as you give me the line. Now, if I'm going to do it off the intercepts, just to show you. Of course, you put 0, x-intercept 0 in for y. 3 times 0 is not even worth me writing. It's 0. X equals 6. And of course, our intercepts, if we're going that route, should be ordered pairs because they're points. And then I'm going to do the y-intercept. And again, bless you, you can mostly do these from your head. Y-intercept, you put 0 in for x. So 2 times 0, which again, I wouldn't really even write all of this. 2 times 0, of course, 0. I can solve that, I get negative 4. Or, of course, ordered pair, we put 0 in for x, negative 4 for y. Plot them both. So I plotted 6, 0, my x-intercept, 0, negative 4, and I'm going to draw my line. Okay, now, again, you could do that with less work, clearly, than what I did it, too. If you're like, I don't really like that. That's kind of a pain. I like my mx plus b. Use your mx plus b. You can solve this equation for y. I'm going to subtract 2x over. And then, of course, divide everything by negative 3. So you've got 2/3 for your slope, and negative 4, of course, real shock on the negative 4, for your y-intercept. So you can mark it out off of this. Y-intercept negative 4, up 2 over 3, up 2 over 3. Draw it. I don't care how you do it, whatever is quickest and easiest for you. I just like to show you both styles. So any questions on that guy? Just a little general form, just to start it off. Okay, write an equation of a line in general form that passes through those points. Now, of course, final answer general form doesn't mean I'm starting in general form. I'm taking a look at that and I'm like, oh man, I need the slope. Always, I need the slope first. I didn't give you the slope, so that's the very first thing I'm going to calculate. So I'm using my y2 minus y1. You know how to do slope. I just do the formula on there for a reminder. So y2, negative 1, minus y1. x2, my second x, minus the first x. So I've got negative 4 on the top, negative 1 on the bottom. Let's put it as 4. Next, I'm looking at my points. I'm like, oh man, I hope one of those is the y-intercept, because I could get an equation quick. And I'm like, crud, none of them are the y-intercept, because you would have to have x as 0. So I'm just going to pick my first point, and I'm going to use point slope form. Point slope form. Y minus the y coordinate of the point equals our slope. X minus the x. So right now we are in point slope form. Final answer, we have to get it down to general form. Is that equal to 0? First I'm going to, of course, clear the parentheses. And then it's really up to you which side you want to make your 0. If you want to put the 0 on the left or the right, clearly, I don't really care. It's completely up to you. I don't know, I'm going to 0 this side out. So I've got my 0, my 4x minus y plus 7. And of course, if you put them all on the other side, you're going to have opposite signs here, whatever. All right. And of course, just one, let me wait till everybody's done writing here. I'm going to click it back a couple slides for you. So just to point out one thing, I'm going to come back to this. Just on the general form, this is just whatever. Notice, of course, the order matters. You have to have x first and then y in the number. So just check details. X, y, all right. Just make sure you have the correct order. X first, y, then the number. I don't care if you have them on the other side and switch, whatever. That doesn't bother me. All right, our parallel and perpendicular slope. Okay, thought I'd throw my parallel line picture on there for you because I'm really sure you forgot what those look like from last year. Parallel lines, of course, never ever intersect. What makes them never intersect is that they have the same slopes. So two lines are parallel if and only if their slopes are the same. If and only if, a nice biconditional statement there, a little throwback to geometry, couldn't help myself. Okay, perpendicular, of course, makes right angles, definition of perpendicular. Two lines are perpendicular, if and only if their slopes are opposite in sign. So you need one positive, one negative, of course, and they have to be reciprocals. Which, remember, just means you flip the fraction. So if you have 2/3, you make it 3/2. Flip it. So double flip, I always think of perpendicular. I got to change the sign, and I have to flip the fraction. Parallel, I use the same. All right, let's do some parallel perpendicular. Find an equation of the line. Oh, okay, now they're back to slope-intercept form for an answer. Cool. That goes to that point and is parallel to this equation. Now, we're in general form. You know, I don't really love general form. It's not super helpful to me. What I need off this equation is I need the slope of it. So what I'm going to do is solve it for y, put it in mx plus b style, and then figure out the m. So I'm going to solve for y. I'm going to subtract 4x and subtract the 5 over. You could have subtracted 6y, of course, too. And I'm going to divide everything by 6. Bless you. Okay, let's reduce. So 2/3, 5, 6. I'm glad I don't have to graph it. Okay, now what I care about, of course, is the slope of this line, the number in front of x. We are making ours parallel to that, so I'm stealing that slope. I don't have to change it. I'm going to use -2/3. So I'm just going to copy that down for my line that I got to write. And for mine, they want it to go through 5 too. So again, I'm looking at my information. Point, slope. I'm going to use point, slope, form again. Y minus the y coordinate, the slope. X minus the x coordinate. Now you're in point, slope, form. Okay, directions. I want it in slope intercept, so I want it mx plus b style. I want to solve for y. So I'm going to distribute. We might have to deal with a fraction. Look out. 2 negatives, of course, make a positive. 2 times 5, 10. You have 10/3. You know I love a fraction. And I'm going to add 2 over. Okay, let's see if we can do the fraction work in our heads. So I'm thinking about 2 over 1. I want it in thirds. 2, of course, is the same as 6/3. So 10/3 plus 6/3, really, 16/3. Glad I don't have to graph that. there's my final answer in slope-intercept form. Intercept would be 16/3, super glad I don't have to mark that guy out. So any questions? So the only thing you needed on that first equation was the slope. After that, you're done with it. So let's do one, of course, perpendicular. Find an equation line, slope-intercept form that's perpendicular, passes through the origin. I'm just going to jot down the origin. We all know the origin's at 0, 0. Now, perpendicular. Same thing. I need the slope off of that equation. So same thing. It's the same equation. Same equation as the last one. So the slope on the last one when we did it, I'm not going to resolve it for y. It's the same thing, was negative 2/3. If I'm going perpendicular, what am I using for a perpendicular slope to negative 2/3? Positive 3/2. So I'm going to jot that down on the next one. We're going to use, for my perpendicular, there's my geometry symbol. How you'd like that. Okay. And we need it in slope-intercept form. Guess what? We're pretty much done. Is 0, 0 on the y-axis? It's also on the x-axis too, but it is on the y-axis, what I really care about. So there's your y-intercept. Y equals our slope times x plus our intercept. I can't say as I would really leave that plus 0 on my final answer. I just put it on for dramatic effect. Got it. So kind of nice, kind of nice. You were given the y-intercept, so you didn't have to do all that work. Now let's say you're just in the zone and you're just doing the same thing over and over. Could you do your y minus the y coordinate equals the slope x? Would that give you the same answer? Yeah, it's just more time consuming. But again, if you don't recognize that y-intercept, you will get the same thing. You're just making it harder on yourself. All right, last thing we're looking at here, a little geometry application of the day. Show that the points are the vertices of a right triangle. God, I love the connection to geometry. Okay, right triangle has a right angle. I'm not going to graph it. There's no graph grid. So there's some perpendicular segments to it. So, of course, perpendicular, we know, is all about the slope. So I need to find some slopes here and check for what's perpendicular. Now, your triangle, put down a little right triangle here. I'm not going to plot it. This is totally just a rough sketch, just so it's in front of us. Show that the points P, Q, R are the vertices of a right triangle. So it doesn't matter where you start labeling. If you want this to be P, 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 I don't care. I'm standing here, P, Q, R. So I'm going to find the slope between P and Q. I'm going to find the slope from Q and R, and P and R. I'm going to do the slopes on all three segments. Because I don't know that that's really where the right is. I'm just kind of drawing a rough sketch. Pretty rough sketch. So I'm going to do the slope for PQ first. So I'm doing my y2 minus y1. So PQ, 17 minus 3. And then x2 minus x1. So I've got 14 over 5. Okay, all right. Now, I don't care if you do QR next, PR next, I don't know. That's a gamble. Let's do PR. Y2 minus Y1. So look at R, Y2 minus P3. R, and move the thing, 11 minus 3. So 5 minus 3, 11 minus 3. Reduce. Okay, all right. Now, I might have kind of chosen unlucky here, so to speak, because are these perpendicular, what I got right now? This 14/5 and 1/4 perpendicular slopes. Now, if they were, I could stop, but they're not. So I do need to do the other side. So I did PR, I got to do QR. QR. Okay, so Q and R. 5 minus 17. And then 11 minus 8. All right, 5 minus 17, 11 minus 8. Oh, now I know, Now do I have some perpendicular slopes up there? I sure do. Okay, so I chose kind of unlucky. If you would have chosen these from the get-go, you could have stopped. You wouldn't have had to do the third calculation. But of course, didn't choose wisely, so to speak. So show a course, I'm just going to say perpendicular slopes. Perpendicular slopes. And of course, makes a right angle. There's my verification that it's a right triangle. Got it. So all off the slopes, maybe you'll choose better than I did, and you only have to do 2. You don't have to do all 3. All right, graphing, here we go, a little graphing calculator for you. Graphing a family of lines. Use a graphing calculator to graph the family, no typo there, forgot the T. Okay, the family of lines, y equals 0.5x for all of those. Okay, now, so we're going to have a lot of lines, because they want you to use -2 for B, then they want you to swap that out and have -1 for B, oh man. Then they want you to change that out to a 0. And then we want to try a 1 for B. And last but not least, a 2. Okay. 5 of them. 5 equations you got to graph. And you're welcome to graph it and look at it like it says, but I don't even really feel that's really quite necessary. Because our common theme here, all the lines are going to be how? Parallel. So you're just looking at more and more parallel lines. Do I need to really type that in my calculator and look at them all? I don't think I need to. But you're welcome to actually verify and look at them all. They're just all parallel lines. Same slopes. Work smarter, not harder. If you need to graph them in your calculator to see the parallel lines in front of you, be my guest. But hopefully we can see right from there it's going to be parallel. All right, last thing. Here we go. Little application problem. A swimming pool is being filled with a hose. The water depth, y in feet, in the pool, t hours after the hose is turned on is given by that equation. Find the slope and y-intercept. All right, well, that's not very hard. Slope, of course, is still our number in front of x. They're using t, though. That's fancy t. So my slope, of course, is 1.5. And then my y-intercept is going to be the 2. Now, y-intercepts, of course, we should be writing those as ordered pairs, 0, 2. That was dramatic, but there we go. Now, last thing of the day. What do the slope and the y-intercept represent? Okay, let's talk about the 1.5. So they just want you to explain what does that really mean in terms of this problem. You're filling a swimming pool. The water depth, y in feet of the pool, t hours after it's turned on is given by this. So what does the 1.5 mean in terms of filling your swimming pool? It goes up how many feet every hour? 1.5. It increases by 1.5 every hour. So I'm going to say the pool water, I'm going to abbreviate water, increases by 1.5 every hour. I'm going to throw a label on. I'm feeling fancy today. Okay, last thing. So remember they're using t instead of x. When your time is 0, the depth of the pool is 2. So you started to fill the pool when it had 2 feet in it already. So I'm going to say the y-intercept represents the beginning depth of the pool. Or the starting depth, whatever you want to say. Good. So any questions? That's like the easiest word problem we've done this year. Any questions on that guy? So today you've got parallel, perpendicular, and then the new exciting thing,